Assalamu alaikum, student. Welcome to another lecture of Slate. This is me, Khawaja Yasin. Let's study chemistry. Well, students, your O-levels chemistry was very basic. Hats off to all of you that you cleared it well. But now when you are in A-levels, you will need those concepts of O-levels. But then we will add a lot to those concepts. Again, that is not a very difficult thing. Because if you have a strong base from O-levels, so that will help you. And even if you don't, that's what we are here for. You can see all the other videos on our channel for the O-level videos. But then again, whenever we are studying an AS concept, we have to revise the O-levels concept. So in today's lecture, we are going to talk about the electrons, the energy levels, and the atomic orbitals. That's a very basic thing, the energy shells or the energy levels that you have studied in O-levels. For your case, it was the same way. It used to be the same way that you have a positively charged nucleus in the center, and then the shells. First shell, second shell, third shell, fourth shell. You can also call them K, L, M, N, O, P. That's a different thing, but again, that's not a thing that you need to remember. But know for sure that you had the numbers of shells. But now, we do call them energy shells or energy level. But now that we have another term for these, which is how it is mostly mentioned in levels, which is principal quantum number, represented by N. So you must be thinking that chemistry mein most of the terms, most of the symbols are N. But then again, principal quantum number is also N. So energy shell can also be described as it's a principal quantum number. For instance, this is the first principal quantum number, second principal quantum number, third, fourth. Remember from the previous concepts, first shell will have 2 electrons. Second shell will have 8 electrons. And you had studied till the first 20 elements in your O-levels. Now we're going to take a step forward. You did study that third shell can contain up to 18 electrons. But normally you always drew 8 electrons and then we jump towards the fourth shell. If you remember that, that's great, but we will be practicing them. So why is it that so? There is another concept. Now we are going to break them down again and again. First, we have shells. Shells contain subshells. Every shell has one or more than one subshells. Why am I saying one? Let's talk about that. But first, we need to talk about the types of subshells. There are 4 types of subshells that you will study about. But let's first name them. S subshell, P subshell, T subshell, lastly, F subshell. You're lucky enough that in AS level, that is what you have to cover. S and P subshell. D will come in A2, and a very important chapter for A2 students, transition elements. And from the last year's trends, most of the questions are coming from that one chapter. D subshell is also important. So the concept would be here. And F, I had studied about the F subshell when I was doing MPhil. So that's a long journey. If you want to pursue chemistry, only then you'll be studying about the F subshell. But today, we're only going to talk about the S and P subshell. So first, these subshells, obviously, they further contains electrons. Now, talking about the S and P subshell. S subshell and P subshell. They have different types of shapes. S subshell is the easiest one. It has a spherical shape. But the next shape, even if you twist a long balloon this way, there is like a small interjoint in the center, just like this one. And for the gym freaks, that's a very interesting and intriguing fact. We call this dumbbell shape, the ones you lift in the gym. So even chemistry is about gym. Chemistry is about working out on these examples. So dumbbell shape. So it's S subshell and P subshell. These are the subshells that we know about, that we will talk about today in this lecture. We won't talk about the D1, we won't talk about the F1. Each subshell contains a good number of electrons. So there is a rule that the S subshell can contain a maximum of 2 electrons. P can have a maximum of 6 electrons. D can have a maximum of 10 electrons. And F can have a maximum of 14 electrons. As you see, there is an increment of 4 electrons when we go from one subshell to another. So that is how it's easier to memorize. So that is the amount of electrons that a subshell can have. So let's further talk about this whole concept in a different way. Let's make a table first. Ignore this diagram, students, at this point. So let's talk about the principal quantum numbers that we have. N. If we have N1, 2, 3, 4, 5. Let's take till 5. So the subshells that we have in the N. Or let's first talk about the electrons. The first one can have 2 electrons. Second one can have 8. Third, 18. Fourth, 18. And then we jump towards 32. We will study why. It is because of the subshells. So let's quickly talk about them. If we have, now which subshells are involved? When we have the first principal quantum number, first shell, obviously it can only contain 2 electrons. So it has only S subshell. What about the second principal quantum number, second energy level? Eight electrons. So it has 1 S and 1 P. What about the third one? It has 1 S, 1 P, and 1 D. Fourth, S, P, D. Fifth, S, P, D, and F. So that is how we're going to do. But one major concept, if it's the first principal quantum number, you add 1 here. If it's the second, you add 2, 2, 3, 3, 3, 4, 4, and 4, 5, 5, 5, 5. Let's quickly calculate the number of electrons. How do they contain this number, these much electrons? S, it has 2 electrons. P, 6, D 10, F 14. Just add the number. 2 into 6, 8, 2 plus 6, 8, 8 plus 10, 18, 18 plus 14, 32. So on and so forth. 6th and 7th will have the same 32 electrons. That's the maximum. So this is the concept of subshells. But subshells are further divided into orbitals. So the next concept is orbitals. Orbitals are the space where the probability of finding an electron is the maximum. This is just a diagram. It's a Heisenberg principle. Again, that's not in your course. But orbitals are the space where the probability of finding the electron is the maximum. Rule. One orbital can have a maximum of 2 electrons. One orbital can have a maximum of 2 electrons. So that is an important concept that we need to understand. It cannot have more than 2 electrons. So each subshell is further subdivided into subshell orbitals. So for instance, S subshell, it contains 2 electrons. So how many orbitals will there be? Obviously 2. So 1 orbital. 1 S orbital. P subshell, 6 electrons. So since 1 orbital can have 2 electrons, what about the 6 electrons? They will have 3 p orbitals. And then they are named as px, py, and pz. These are the 3 orbitals. So let me show you the images. You will, in the exam, you will have to draw the diagrams as well on the axis. So at first, s orbital, no rule of x, y, or z orbital axis. S is spherical. This is the s orbital, and that is something that you need to know. Easy. It's a sphere. P orbitals. Now there are 3 p orbitals. Px, py, pz. Talking about the px one, it's the one which is on the p-axis. Y, py is the one on y-axis. Z on z-axis. So that is something we know about the orbitals and their shapes. Normally, all 3 p are joined together. It's a very messy diagram. You're not supposed to make them in the exam. In the exam, they will ask you this way. They will give you the axis. So it's a z-axis. If you don't recall, it's this way. These two are x and y axis. But normally the z-axis goes this way. But obviously you cannot go out of the plane in the exam. So we make a diagonal z-axis. So they're all 90 on a 90 angle to each other. They're all right angle to each other. So these are the orbitals that we have. So in the elements, the electrons will be divided this way. But before that, talking about the energy levels or the energy shells, if we call an energy level 1 versus energy level 2, we know for sure energy level 1 will have lower energy than energy level 2. This will have a higher energy, and the 3 will have more energy. So that is the concept of energy. So if I look at this diagram, if I show you this diagram, I have an electron here. And if I have to transfer this electron to this energy level, obviously I will have to give more energy, because from 1, if it's going to 2, I will have to add more energy. So this is called excitation of electrons. Sorry for this digital error, it happens. Now, if I have an electron here and it has to go to a lower subshell, it will give out energy. So that is de-excitation. So that is the whole concept of excitation and de-excitation. And when we talk about the energy of the subshells, so know for sure S, P, D, and F. F will have a higher energy than D, and D will have a higher energy than P, and so on and so forth. This is something we know about their energies. So S has always lesser energy than P, and P will always have lesser energy than D. So, in the case of electronic distribution, we keep on adding electrons. Electronic distribution, the concept is electrons are filled in the lower energy orbital first. Electrons are filled in the lower energy orbital first. So you would know which has the lower energy. So let's talk about one of the elements, a few elements today. We will discuss further concepts in the next lecture, but we need to discuss a few examples. For instance, we have hydrogen, one electron. Where would that electron be? It would be in the s orbital. But which s orbital? 1s1. What do we know about helium? 2. So 1s2. Talking about lithium. While we are discussing about lithium, we have 3 electrons. First, they are going to fill 1s2. Then we will jump on to the next shell and next orbital, 2s. But we are only left with 1 electron. So 2s1, that's lithium. Beryllium, 4. 1s2, 2s2. Boron, 5 electrons. So obviously 1s2, 2s2. But now 1 electron is left. Now we will jump to the third orbital, which is, at first we are only going to talk about the subshells, Abhi. So 3, sorry, is the second one, 2p1. Carbon, 1s2, 2s2, 2p2. Nitrogen, 1s2, 2s2, 2p3. Oxygen, 1s2, 2s2, 2p4. If you can observe, I'm just adding 1 electron one by one. Fluorine, 1s2, 2s2, 2p5. Neon, 1s2, 2s2, 2p6. Let's talk about sodium, and that is the last element for today. Sodium, 1s2, 2s2, 2p6. We're still left with 1 electron. And obviously, with neon, the shell was ended, and also p orbital, p subshell cannot have more than 6 electrons. So we will have to start over from a new shell. So 3s1. So that is something we know about these. But in O levels, you do the electronic configuration with the shells. Now we're going to make boxes. Let's write the rules first. Boxes will show orbitals. And since it's an orbital, a maximum of two electrons. But how do you show electrons? This is if this isn't the case if we have only one electron. But what if we have two electrons? I cannot do it this way. I cannot do it this way. These are parallel spins. Electrons normally have opposite spins. So wrong, wrong, and let's do it with green, the right one. You can do it this way as well. You can make a full arrow as well, but half arrows are more suitable. So that is how you're going to show the orbitals. And then S will be shown by this. P will have 3. D will have, sorry for the shape, 5 orbitals. So an important term that comes here, all orbitals in a subshell are, this is an important term that you need to mention in the exam as well, degenerate. What do we mean by that? Having same energy. So let's start by filling the elements that we talked about today. When I said sodium was the last element, I did not mean the lecture was ending. We still have a lot to discuss. So hydrogen, just one subshell, one orbital, so one block. 1s1, so one electron. So that is the electronic configuration of hydrogen. Helium, one block. One goes this way, one goes this way. That's also right. Lithium. Then you'll have to make all 3p together. One electron. Now this is an important part. Just note it. Be awake. So for beryllium, we have 2 electrons. Now we have the p orbital. Sorry. Oh, I did not notice it. Let me do it again. So till now we are at 2s. This is 1s. This is 2s. And this is also 2s. For boron, the concept changes. So this is the first one. This is the second one. 1s, 2s. Now we'll jump on to the p1. This is 2p. So boron, 1 electron will be added because just 1 is left. So for carbon, note that this is important. This is what I wanted to say pehle, but now it makes sense here. When I mentioned 2 rules today. Electrons fill in the lower energy orbitals first. Perfect. That is why S was being filled first, then 2s, and then it's the time for 2p. But I also said it's something that all orbitals in one subshell are degenerate. They have the same energy. So if I fill it up this way, so this would mean that this orbital has more energy than this one. But that is not the case. The case is they all have equal energy. So this one will be filled first, not the first one, because they all have equal energy. For nitrogen, and this is what we call, we will study this concept in detail. This is a half-filled orbital, a very important concept. Oxygen, again, let's quickly draw them. 3 were already filled. Now we add another one. Fluorine. One is left. And the last, neon. 2 electrons in each orbital. Obviously, now we don't have space to add more electrons. What will we do? We will add 3s2. With just one electron. It's better to label them 1s, just 1s, 2s, 2p, and you can also do it this way 2px, 2py, 2pz, and this is 3s. So that is all for today. In the next lecture, we are further going to discuss the anomalies, which are different rules, which will go off the trend, and we will have shortcut ways of how to write these electronic configuration. Because obviously, if I talk about calcium, if I start from 1, 2, P, S, then again S, then P, then S, then D, that will be a long one. So there are shorter ways to write these. But that we'll discuss in the next video. Thank you so much for being here with me. Allah Hafiz. Best of luck.